record. So basically, what is alternating current, guys? It is a current which periodically changes its direction. The direction has to be changed or basically reversed after a fixed interval of time, and the magnitude may or may not change. So depending upon that, you have different alternating current. I'm drawing diagram. This type of current is basically called as the square wave alternating current. Square wave alternating current. What is the time period for this? Can you see after this much time period, it is again going back to the same cycle where it started from, right? So the cycle is repeated after this much time. This is one complete cycle. Right or wrong, guys?
Yes, sir.
So anyways, this is basically your square wave square wave AC. Some, other type I can draw. I can draw a triangular wave AC as well. Sir, what is a triangular wave AC? Can you see? Can you see over here, guys? Here, let's say this is time equals to t by 4, this is t by 2, this is 3t by 4, and this is time t. Till here, it's one complete cycle, and after this, it will keep on repeating, right? Can you say here in this case, what is happening during the time interval 0 to t by 4, the current is increasing its magnitude. Direction is still positive, okay? It reaches to a maximum value, why not? And then what happens? Then it starts decreasing till a time between the time interval t by 4 to t by 2, it keeps on decreasing. And it's then what happens after that, the current at this particular time becomes 0 in the circuit, and then the current starts increasing in the negative direction, and that implies in the opposite direction, reverse. If let's say clockwise is positive, then here the current will go anti-clockwise, right? Are you getting my point? And then again at this time it becomes 0, it becomes maximum but in the negative direction, and then it becomes 0. So this is again another type of AC which is basically called as triangular wave AC. So different types of alternating current may occur. The most common alternating current which we are going to study is basically called as a sinusoidal wave AC. What is a sinusoidal wave AC?
Follows the
Depends
sign.
on the sign, sign.
No, it
Component.
does not depend upon the sign. The function to represent this is basically a sine theta cos theta. Do you remember sine theta cos theta? Trigonometry.
Yeah.
So basically
Yes,
the
sir.
graph just looks like a sine curve, sine or a cosine curve. So basically that is why the term sinusoidal AC wave. Okay, sinusoidal wave AC, whatever you want to write. So how does it look like? It looks like this. I'll draw it for you. The diagram may not be perfect, but you please draw it perfectly. So can you see at one particular side, this is a sine curve. This is the graph for a sine curve. The equation looks something like this: y equals to a sine omega t, right? Something like this. We'll see the equation. Don't worry. Right now I'm just doing the graph, and I'm telling you that these are different types of. This is t by 2. This is t. This is 3t by 2, and this is 2t. Is this clear, guys? What is one cycle? Please remember what is one cycle. Can you see in the positive cycle it goes to the maximum, it comes back to 0, and then it goes in the negative cycle, goes to the maximum. So this part is basically called as the positive cycle, and this part is basically called as the negative cycle. Similarly over here as well, positive cycle, negative cycle, positive cycle, negative cycle, positive half cycle, negative half cycle. Okay.
Yeah.
Okay. So please remember these are your basically positive half cycles. We'll come back to what half cycles and full cycle is, and this is called as negative half cycle. The important thing to note is basically the time period, है ना? कहाँ से कहाँ तक? So this is your alternating current. Clear? Acha. Please remember, if the current in the positive half cycle and negative half cycle are equal. So basically, if the current exactly how is flowing in the positive cycle, exactly it flows in the negative cycle, then it's called as a symmetric AC wave. So can you see in all the diagrams which I have drawn, the positive current and the negative current, they almost look like the same, right?
Yeah.
So basically these all the diagrams which I have drawn are for symmetric AC wave. Otherwise they are called as asymmetric. Although asymmetric is not there in our syllabus, but still it exists. I can, do it like this. Can you see? This is a asymmetric AC wave. I just given you an example, है ना? It's not necessary. This is the only asymmetric example. It's square wave in the positive cycle and triangular wave in the negative cycle. I'm just giving you an example. Clear?
Yeah.
Now, please write the heading. The more I told you now, the main important thing is basically the sinusoidal AC which we need to discuss. मेरी क्लास है अभी क्लास अभी चल रही है sinusoidal AC and its generation. How exactly is this sinusoidal AC? Do you remember this thing, guys? When you had this magnetic field, a uniform magnetic field in space, and let's say I have a current carrying loop, okay? And what will happen if I start rotating this loop? Do you remember, no? Okay, when this loop starts rotating, what happens? EMF starts generating, right?
Yeah. Yes, sir.
So in this particular case, what will happen? The flux, do you remember, guys? If at any instant, suppose this is the magnetic field and let's say this is the area vector at any general time. Let me change the color. This is the area vector at any time when I rotate the loop by a small angle theta. If I rotate the small loop by theta, so can you see initially the area vector was also acting into the plane, right? But when I rotate the loop by an angle theta, what happens? When it in the loop area vector also changes, right? So now what happens? At this particular instant, area vector and magnetic field are making an angle of theta. So here at this particular time, the flux which passes through this surface, can I say if the number of turns is n, if the magnetic, so n is the number of turns, b into a into cos theta, right? And can you see over here, if I was rotating it with an angular speed of omega, then this thing theta, will theta be equals to omega times t? So can I write phi is equals to nba cos omega t? Can I write this phi? And from
Yes,
the
sir.
next chapter, electromagnetic induction, we understood this particular thing. Basically, if I want what is the EMF produced, so EMF produced will be basically what? The magnitude of EMF will be d phi by dt, right?
Yes, sir.
So when I do this particular thing, when I integrate this, differentiate this thing, just the magnitude part, will I get n into b into a into omega sine omega t? Why did this omega came and multiplied? Because do you remember when we differentiate, the chain rule will
Yeah.
apply on this particular thing. We differentiate it with respect to time. So it will become n into b into a into omega sine omega t, and I can say this whole thing is basically the maximum value of EMF. So can you see this particular thing? E is equals to E naught into sine omega t. So what is this? Is this a sinusoidal EMF? Yes or no?
Yes, sir.
And if you connect this sinusoidal EMF in a circuit, then the current which flows will flow according to this only. So when this changes its direction, automatically the current also changes its direction. So you understood how exactly sinusoidal AC is generated, right? Sinusoidal
Yes,
current
sir.
is generated. Yes or no?
Yes, sir.
So you can write note when a loop rotates in a uniform magnetic field, it produces a sinusoidal EMF, and due to this EMF, a sinusoidal current is generated in the circuit. Is this clear? What is the cause?
Sir.
Yes, tell me.
So when we're like differentiating the flux, like we'll get minus sine omega
That's
t.
why I told you only magnitude I require.
Okay.
है ना?
Okay, sir. Yeah.
So, anyways, AC source, like, do you remember, guys? A DC source has a symbol in electric circuit. DC source looks like this: positive, negative. A DC source, a battery looks like this, right? Similarly, an AC source also has a symbol. AC source looks like this. You'll draw a circle and you'll write this S, which is rotated by 90-degree anti-clockwise. S rotated 90-degree anti-clockwise, है ना? So make this is the symbol for your alternating current. And this AC source may be a AC generator. It may be acha, AC generator is also called as alternator, है ना? It may be a dynamo. It may be um, an electric oscillator, right? It can be any of these particular sources. All of these sources are basically source of what? AC. Is this clear? Now this sinusoidal AC, this sinusoidal EMF, so due to E equals to E naught sine omega t, a current is produced. A sinusoidal current is produced in the circuit, and this current will be basically what? Do you remember? I is equals to basically E divided by the net resistance of the circuit.
Yes,
So
sir.
it will be
Yes.
E naught sine omega t by. So can you see over here? This I can name it as I naught. So the current in the circuit is basically I naught into sine omega. This equation of sinusoidal AC. AC. Is this clear?
Yeah.
Generally, this equation I can write it as general equation for AC. I can write it as I equals to I naught into sine of omega t plus phi. We'll discuss each and every term, what exactly are all these terms, right? They want me to discuss it now only ki later on? We'll discuss it later exactly, not now. If now it's not required. Please remember, what is the difference between the first and the second equation? The first equation looks like this. I'll tell you, although I'll have to do it again later on. The first equation looks like this. This is basically I equals to I naught sine omega t. The next diagram I can draw is something like this. Can you see over here? This is not starting from origin. It is starting from some other position, right?
Yes, sir.
This is because of that theta, sine of omega t plus phi, and this phi, and this phi is less than 90 degree. Then this kind of graph forms. We'll exactly look how it forms, है ना? And if it is in the form of cos omega t, so when it is cos omega t, the graph doesn't start from mean position, it starts from extreme. Okay, so this is t by 2, this is t, this is 3t by 2, this is 2t. Similarly, this t will lie somewhere over here, 2t will lie somewhere over here, 3t by 2 will lie somewhere over here, and t by 2 will lie somewhere over here, t will lie somewhere over here, 3t by 2 will lie somewhere over here, and 2t will lie over here. Similarly, this will be your t by 4, this will be your t by 2, this will be your 3t by 4, and this is where t will be. This graph is for I equals to I naught cos omega t. So for now, you just remember that whenever it is sine, it starts from here. Whenever it is sine omega t plus phi, then it starts from somewhere in the between. And whenever it is cos, it starts from the extreme, right? Just remember the graph as of now. Is it clear, guys? Guys, is it clear? In this general equation, let me tell you what exactly each and every term means. Are you done with drawing the diagram? Once you're done, just tell me. Acha, where here this t which I am writing, what is this t? T is basically the time period of right. This is the time period of AC. Clear, guys? Guys, is it clear?
Yes, sir.
Sir.
What is I? I is basically the instantaneous current in the circuit. What is I naught? I naught is basically the maximum value, or you can say the peak value. Maximum or peak value of current. Omega is basically called as the angular frequency of AC. What is angular frequency? Angular frequency is basically 2 pi into normal frequency, or it is equals to 2 pi by t. This is the relationship between angular frequency and, I think everyone is already aware of this thing.
Yes, sir.
Omega is this. F is basically the frequency. T is what? What is small t? T is basically the general time. Instant. Acha. Whatever, just for example, I equals to I naught of into sine of omega t plus pi. You write it like this. This is the general equation, right? Yes or no, guys? So this thing, whatever you write in the brackets of sine, this thing which you write is basically called as the phase of the alternating current, the phase of this current, right? We'll see exactly what is phase, don't worry. What is this phi? phi is basically called as initial phase of an AC. This phi is called as initial phase of an AC, right? We'll see what does it mean later on in the chapter. Abhi nahi. Abhi ke liye I'm just introducing the whole equation to you, so that you won't be doing this. Anyways, acha, why it is called as initial phase? Can you see at t equals to 0, the phase, which is basically what, omega t plus phi. Can you see if I put t equals to 0, this will become what, phi, as t is 0, right? So can you see initial phase is basically phi? Are you getting my point? Yes or no, guys?
Yes, sir.
Yes, sir.
So everyone understood what exactly these terms mean. This is the instantaneous current. This is the maximum or peak value of current. This omega is basically the angular frequency. T is any general time instant. Phi is the initial phase. This whole thing in the bracket is basically called as the phase. Omega can be written as 2 pi f or 2 pi by t. It's up to you. Here, phase of AC at a given time instant t. Everyone understood the basic terminology is used in alternating current?
Yes, sir.
Now please write some points, and सबसे पहले, in India and UAE, the frequency of AC which we use is basically 50 hertz. The frequency is 50 hertz. That implies F is 50 hertz. Please remember, if F is 50 hertz, what is the time period? 1 upon 50, which is basically 0.02 seconds, right? And what is omega? 100 pi. Can you see 2 into pi into 50? So 100 pi radian per second. Is this clear, guys? Hello, people.
Yes, sir.
So this is the angular frequency in India and UAE. Generally, we use this. Always remember, if you want to convert from AC to DC, you need to use a device called as rectifier. We'll study about these rectifiers. And if you want to convert DC to AC, you use something called as inverter. Inverter, the one which we generally people have in at home, right? Light chali aati, to inverter se light aati hai. So that is basically inverter, and a DC to AC inverter. Acha, there is again one more device, AC to AC. It can be increased AC or decreased magnitude AC. So basically this device is basically called as what? A transformer. AC to AC is basically a transformer. That transformer can be step up or step down. ये सब पढ़ना है अपने को, by the way, है ना? We don't need to study this, but ये and ये we need to study in this chapter. ठीक है? अच्छा, there is one important point. I think you might ask your chemistry teacher. AC current is never used in electroplating or electrochemistry. Ask me why. Or
So
try
after
to
some
apply.
time, the cathode and anode will be changed, right? So
हाँ, so आगे
So the coating won't be done like
Exactly. Because for the coating to be done, the ions needs to move from one plate to another plate, right? And if you keep changing the polarity of the cathode and anode, it will never happen. The ions will never move towards, the positive ions will never move towards the cathode, and the negative ions will never move towards the anode. It will always keep on, just oscillating in between the electrolytic solution. Are you getting my point, guys? So we can never, AC cannot produce, chemical effects of current. Always remember this. I am not writing this, that thing, but anyways. Next heading, please write average value of alternating current. Please write down average value of alternating current. Done, guys? Hello, guys. Shall I start with average value of current?
Yes, sir.
Yes, sir.
So what is average value of current? Suppose. पहले concept समझते हैं. Let's understand the concept first. What is this average value of current? Suppose if there is a circuit, any circuit, whatever electrical circuit is there, and you connect it with a AC source, right? Or not necessary with an AC source. Let's say any source, AC or DC, doesn't matter. कोई से भी source है, you connected. So if I try to draw the graph for please remember, graphical analysis will play a very big role in this chapter. So suppose if I try to draw a graph, and let's say this is the this is the graph of current as a function of time, right? This function can be constant, this function may be dependent on current, so whatever is it, doesn't matter. Now if I try to integrate this current between two limits, x equals to, let's say, time equals to t1 to time equals to t2, if I integrate current, which is basically a function of time, so I integrate current with respect to t1 and t2, will it give me the area under the IT curve? Will it give me this?
Yes.
This area between the two limits I'm integrating, will it give me this area, right?
Yeah.
By definition, everyone
Yes.
knows this is the definition of graphical interpretation of integration, right? And what is this? Current with respect to time we are integrating, is it the average charge which is flowing?
Yeah.
So always remember ki whenever someone talks about ki what is this area represent, I'll just write it over here. So this area under the IT curve is representing what? The charge, average charge which is flowing through the, it represents the average charge flowing during T equals to T1 to T equals to T2. In spite of writing average side, you can just write total charge. You know, the total charge flown during T equals to T1 to T equals to T2 in the circuit, right? So from here, I can define one thing. I can define the average current throughout flowing is basically what? The total charge which is flowing throughout divided by the total time, right? Yes or no? By definition, can I say this particular thing? Average current is basically what? The total time, the total charge flown by the total time taken, right? Yes or no? Can I say this?
Yes, sir.
So from here, can you see this I? What was this I? This I was basically the instantaneous current. And what is this? Is basically what? The average current, right? So from here, can I replace this delta Q by I average into delta T? So from this equation and this equation, can I write, so from 1 and 2, can I write this particular thing? I average into delta T should be equals to integration of I dt from T1 to T2. Can I say this? If I can say this, then can you see from here I average is equals to 1 upon delta T, and can I am sending this delta T towards here, and delta T is nothing but T2 minus T1 integration from T1 to T2 I dt. Is this thing clear which I have drawn over here? Guys, ये clear है क्या?
Yes,
Yes,
sir.
sir.
So basically, what is this I average? I average is basically what? The average current flowing through the circuit from T1 equals T equals to T1 to T equals to T2. Okay. First of all, what is the graphical significance of this particular thing? The graphical significance is basically what? You will convert with the help of this concept what exactly you are doing. Do you remember the current was actually like this? A very random thing, right? Between T equals to T1 to T equals to T2. Yes or no? So by using this concept, you will basically convert this graph T equals to T1 to T equals to T2 only, this. So basically here the current was changing from some value to some value. So basically what will be the, here can you see, by using the concept of average current, the thing in which it was varying, no, you removed this varying thing and now made it a whole constant thing. So can you see over here this alternating current? Can you see this alternating current or whatever current is this, for this variable current to a constant current, you converted this, right? So in between the current which was varying, in spite of varying it, you took an average value in between this time interval and made it a constant current. So this is basically the significance, graphical significance of this particular thing. I'll write it graphical significance. Shall I write it in words? What exactly did I do? I converted this variable current to constant current by using the concept of average current. Is this clear, guys? Shall I write this thing in words? The graphical significance? Yes or no?
Yes, sir.
All right. The concept of average current is used to the concept of average current is used to convert a variable current, not necessary an alternating current, whatever variable current, to a constant value of current. Acha, very important point in this particular thing. When you do this from here to here, the area under the curve, if I say this is A1 and let's say this is A2, can you see the areas are in between the same time interval T1 and T2? They should be done in such a way that the areas should be equal to a constant value of current in such a way that the area under the curve between both the graphs should be equal for the same time interval. Please write the graphical significance and then I'll make you write this thing, the physical significance as well. And I'll give you the logic. I have already, this is the logic. The graphical thing is basically the logic behind the physical significance. So I'll tell you. Guys, can you give me 2 minutes? I'll be just back. Please start whenever you're done. I'll be back in 2 minutes. Give me 2 minutes.
Okay, sir.
Hello, people.
Yes.
So, done?
Yes,
Now
sir.
let's try to understand the physical significance. First of all, tell me this particular thing. Suppose physical significance is what? Basically the definition which you'll use in school, average current, and the physical significance of average current in AC. This is the definition you will write. Can you see basically when you were doing the graph, you were converting this variable to constant thing, right? So this constant thing is nothing but a direct current, right? If we talk about current in the case of direct current is basically a straight line only, right? Hai na? Hello? Hai na? So basically, suppose if I have a circuit and whatever electrical circuit is over here, it can be a resistor, it can be a inductor, it can be a combination, it can be anything. I have an AC source. I want to convert this AC source to a basically to a DC source. Understand this thing very carefully, guys. Na? I want to convert AC to, theoretically I'm not actually doing it. I'm doing it theoretically. I want to convert this AC circuit to DC circuit. In this case, what will be the current flowing? The current which will be flowing will be basically what? It will be a function of time, right? It can be any function. It can be a sinusoidal function. It can be a square wave. It can be a triangular wave. It can be anything, right? So this function, we are trying to replace this function, this current I, with a non-changing value I average in such a way that the charge flowing through this electrical circuit in the same time is same in both the circuits. I'll write it for you, then you'll try to study. So it is that value of DC, it is that value of direct current due to which the same charge flows in the circuit it is that value of direct current due to which the same charge flows in the circuit when AC source was connected. So it is that value of direct current due to which the same charge flows in the circuit which was flowing when AC current was conducted in the same time duration. So can you see, I basically did the same definition on this graphical analysis only. Can you see, in such a way that the area under the curve between both the graphs, and in the case of current time graph, what is the area under the curve? In the case of current time graph, what is the area under the curve? It is basically the charge, right? Yes or no?
Yes, sir.
So basically, can you see, in the same time interval from t equals to t1 to t equals to t2, in both the cases, the same charge should flow. Here, if the charge is flowing delta q, so here the charge should also be delta q. So it is that value of average current, it is that value of direct current for which the same charge flows through both the time, in both the cases, in the same time interval. Everyone understood the physical significance?
Yes, sir.
थोड़ा बहुत एक बार once more. Shall I do once more?
Yeah.
So basically, first of all, understand these key points very clearly. What are those key points? First, area under current time graph gives you
The charge.
which is flowing,
Charge
right?
flowing through.
In between what to what interval? Can you see, from T1 to T2?
T1 to
Here
T2.
also T1 to T2. Can you see the time interval is same in both the cases? So did you understand this particular part? The same time duration and the same charge. Did you understand this part? Same charge and same time duration. Yes or no?
Yeah.
Now after this, can you see in the first case when the current was a variable current, it may be sinusoidal, it may be alternating, it can be any type of current, right? But it should be variable. But in the second case, it is not variable at all. In the second case, the current is a constant value, right? So whenever current is constant, can I say it is a direct current? Yes or no?
Yeah.
So it is that value of a direct current which flows through the circuit, the same circuit, due to which the same charge flows in the same time interval in the case of both the AC as well as DC. So ultimately, you are using this concept to convert this AC to a DC point, right? Is this clear now?
So we're relating them through charge.
Exactly. We are trying to relate both of them, both of the currents with the help of charge. There will be one more current which will be called as RMS, where we'll not relate it with charge, we'll relate it with power later on. है ना? अभी के लिए, is this clear? We're trying to relate both this current, variable current, and this constant current in such a way that the same charge, the area under the graphs, the same charge should flow through the circuit in the same time duration from T1 to T2, from T1 to T2. ये area दोनों equal होने चाहिए. Is this clear?
So, but is this theoretical? Like,
Yes, it is theoretical bit. Actually, there are many complications, but this is all theoretical. It's just an average theoretically value. Actually, so it's only variable current only, no?
Yes.
Yeah.
But for the sake of simplicity, we try to do the average thing throughout the whole time.
Sir, I don't understand one thing. Like, we're talking about AC current and we see that it's alternating. So then won't the other components need to change their polarity too according to the current that's flowing? Like, I don't get that part of
Won't
it.
the other components, which
Like,
components are you talking about?
whatever components are there in our circuit.
हाँ, मतलब capacitor, inductor. हाँ, so होने दो.
How will we do that?
अभी एक बार मेरे को ये कौन से समझ में है? Once that will come, no? तो उसमें तेरे को बताऊंगा कि polarity से it doesn't affect this thing.
Okay.
Polarity is because of the current flowing. Because of the polarity, current is not flowing. The current is flowing because of the polarity of the source, not because of the polarity of the components. The polarity of the components is defined by the current.
Yeah. Okay.
है
Yeah.
ना? Ulta is the other way around. So anyways, I think it is pretty much clear. What is the final formula which you'll keep on remembering? I is basically equals to I average is equals to 1 upon T2 minus T1 from T1 to T2, the current into dt. Please remember, what is small I over here? Small I is basically the instantaneous current, or basically the alternating current, whatever it. I'll write it. Small I is basically the instantaneous current. If you want to write small I, you can. It's up to you. If I want, क्या लिखूं इसको? Capital I लिखूं क्या? It's fine. And I average is basically the average.
So why is I instantaneous current? Shouldn't it be a function of time?
It will be a function of time, no? If y equals to f of x, then you generally write y dx, right?
Instantaneous means like a magnitude, right?
The magnitude or maybe the direction, it all depends upon the time. Time के साथ में vary होता रहेगा. Here I is basically given as a function of time.
Okay.
Clear? So anyways, this is your definition. Let's try to find out the average value of current in case of sinusoidal AC. Acha, by the way, average and mean, it's one and the same thing, right? So I can write mean value or average value of a sinusoidal alternating current. Okay. So basically what we are doing for I equals to I naught sine omega t. For this current I'm talking about. For basically this thing. If you are not comfortable with writing small I, then you can write capital I, no problem. Capital I dt, capital I is basically the instantaneous current, capital I. If you are not familiar, look, I've changed it. So capital I is instantaneous, I naught is peak value, and I average is average value. Okay. So basically we try to calculate this thing, but we'll try to calculate over two different time intervals. We'll calculate the average value over a full cycle. If it is calculated over a full cycle, that implies the time interval t1 should be 0 and t2 should be t. Can you see the time interval is one full time period, one full cycle, right? Hello. So
Yes, sir.
I'll just
Yes.
write it in the formula. We know the formula for I average, it is 1 by t2 minus t1 from t1 to t2 into I dt, right? So I average will be equals to 1 by t minus 0 from 0 to t. I को I can write as I naught sine omega t dt. Yes. Yes or no? Can you see this
Yes.
I naught is constant, it will come out. This t minus 0 will become t, and I have integration from 0 to t sine of omega t dt. Yes. What is the integration of sine of omega t dt?
Cos omega t by t.
Minus
Psi
cos.
omega.
Minus cos omega t.
Minus cos. Sorry.
So naib upon omega, not t. So you'll write it
Yes,
as
sir.
minus of a cos omega t upon omega from 0 to t, right? Can you see this omega is a constant? Can I take it out of the circuit? And can I write omega is basically 2 pi by t, right? So 1 upon omega is basically t upon 2 pi. So when I take it out of the circuit, I'll just multiply it with t by 2 pi, right? So I naught by t into t by 2 pi, and here I'll have minus of cos of omega t, to minus of cos of omega into t minus of, why am I using the minus twice? In spite of doing this, let me take the minus common. Minus common ले लिया मैंने, and now cos of 2 pi by t multiplied by t minus cos of 2 pi by t into 0. Yes or no? Yes or no, guys? Can I do this?
Yeah.
So this will be minus of I naught upon 2 pi into this t, and this t will get cancelled out. What is cos of 2 pi? Cos 180. Oh, sorry, cos 360. Cos 360 is, what is cos 0? What is cos 0? Cos 0 is 1, right? So can you see over here, cos 360 will also be 1, and cos 0 will also be 1. So can you see minus of I naught into 2 pi, 1 minus 1, which is basically 0. So the whole thing becomes 0. So can you see this particular thing? For a full cycle, the average current through the circuit is 0. Is 0. Yes or no? And logically this should happen. Yes or no? Logically also this thing should happen. Suppose if this was the current which we have taken, so can you see during the positive half cycle, Everyone, can you please see this particular thing? During the positive half cycle, this delta Q was positive, and during this negative half cycle, this delta Q was negative. This area and this area were equal. So what is the total charge flown through the circuit? Is zero, because this thing, let's say delta Q1 and delta Q2, they both are equal and opposite. They'll cancel out each other. Yes or no? So this thing is pretty much valid, right? So since delta Q is zero, automatically current will become zero. Is this clear, everyone?
Current is negative just means it's going in the opposite direction.
Opposite direction. The charge is flowing in the opposite direction.
Yeah.
Is this clear? So I guess I'm pretty much clear about the average, current over a full cycle. It's clear. Okay? Shall we discuss over a half cycle? The second derivation. Acha, by the way, these derivations are there in your school syllabus, textbook also. So please, karna inko. So if I say over a half a cycle, and how will you begin with this particular thing? How will you begin this particular thing? Whenever this derivation comes up, first you will define average current hota kya? You will try to define the average current is basically that value of DC current for which the same charge flows in the same time through in both the cases, right? Yes or no?
Yeah.
So you'll first define the value of average current, and then you'll start with the derivation. I average is basically equal to, you write this formula. I average is basically this, and then over a full cycle or over a half cycle, it's up to you, whatever comes. So if it comes over a half cycle, acha, if I say, let's say I'm taking only a positive half cycle, okay? For simplicity in calculations, I'm taking only positive half cycle. Can you see 0 to T/2 is basically the positive half cycle, right?
Yeah.
So over this positive half cycle I'm talking about. So the same thing, I average is equal to 1 by, and T2 will be T/2 minus 0 from 0 to T/2 I naught sine omega t dt. Do I need to solve the whole thing now? It's fine.
It's fine.
I can come to the conclusion directly. Can you see this will become 2 by t? This I naught will come out. I naught. Integration of sine omega t will become minus of cos omega t, right? So I am just sending this minus sign directly outwards. Guys, is it clear? Cos omega t divided by omega, right? Is it too much? Okay. For now, this much. Is it fine? Guys, is it fine till here? I
Yes, sir.
inverted this T/2. 1 upon T/2 is basically 2 by t. Integration of sine omega t is minus cos omega t upon omega. So I took that minus sign out. Also, this I naught was in multiplication. I took this I naught also out. Till here, good. That is minus of twice of I naught by t. 1 upon omega, I'll write it as t upon 2 pi. And this will be cos omega t. So I can write cos of 2 pi by t into T/2 minus cos of 2 pi by t into 0. So can you see I'm just replacing at the place of t, small t, I replace with T/2 and 0. So this will again be how much? Can you see? 2 से 2 कट जाएगा. Cos of pi. Cos of pi is cos 180. Right? So what is cos of 180, guys?
Minus 1.
Minus 1.
Minus 1. Minus what is cos 0?
1.
So minus 1 minus 1. So this will be equals to minus 2. This minus minus will cancel with this. And the final answer will be 2 upon pi into I naught. So basically this is the average value of current 2 by pi. Achha, when I calculate this 2 by pi, it comes to be 0.637 times of I naught. So can you see this particular thing? if it is 0.637, can I write it as 63.7% of I naught? So basically, whenever you are converting a sinusoidal AC to a DC current, then basically what exactly you will do? You will assume the average value to be 63.7% of the maximum value. I'll write the physical significance, graphical significance, everything. सब लिख दूंगा मैं, टेंशन मत लो. Please remember, for positive half cycle, the average current is basically 0.637 times of I naught. For negative half cycle, when you'll do it, the value of average current will come to be minus of 0.637 times of I naught. You can try and calculate. Okay. What will be the only difference? The difference will be the limits, right? Here you will write what? Here you will write T by 2 and here you will write capital T, right? So from T by 2 to capital T, that is the negative half cycle. So can you see, over positive is this much, over negative is this much, equal and opposite cut marega, so over a full cycle, the average current is 0. Is this clear?
Yeah. So this also affects the work done by the battery for a full cycle. It will be 0, right? Because
एक बार फिर से once more.
so the work done by the battery will also be affected by this, right?
Yes,
Full cycle.
obviously. हाँ, एक बार positive work, फिर next reverse cycle में negative work.
Can you explain कि circuit में क्या effects आएंगे इसकी वजह से? Like I'm not able to visualize that.
Just visualize this particular thing. Due to this, not due to average current, due to a sinusoidal current, just the current ka direction is getting reversed. Just imagine it like this. And whatever effects are current is current producing. अब suppose करके let's say current is flowing anti-clockwise initially or clockwise initially, है ना? So if the current is flowing clockwise initially, you will decide the polarities of the elements accordingly. You will flow the current in the resistor accordingly. You will develop heat accordingly. And then what will happen once you change this thing, change the direction, then the opposite plates will get the opposite charge. The polarity will get reversed. The current will start flowing in the opposite direction. Even still, heat will be released. Even still, some energy will be stored, but now in the opposite direction. So ऐसे करके you need to balance the whole thing. Okay? You need to think again in the negative direction what will happen. So anyways, this is I think pretty much the derivation which you have in your school. There is one more thing which is basically called as RMS value. What is the time right now? 15 minutes है. 15 minutes में discuss कर सकते हैं. We can discuss.
So
Yeah.
the work done by the battery here is negative, or do we add both the work done?
You add both the works and the work done becomes 0 over a full cycle.
Okay.
Matlab, if you just talk about the sign, if you talk about the over a the magnitude part doesn't become 0 because पहले battery has to work in flowing direction and in flowing the current in one direction, and then next cycle, next negative half cycle, the battery has to start working in the opposite direction. So the magnitude is not 0, but that overall is 0 if you consider the sign as well. Right? Okay.
Yes, sir.
But generally, we don't define with the help of negative work. We try to define it in the positive cycle. But actually, magnitude-wise, how much work the battery head is as that. Anyways, acha. Please remember the same results. Note. Same results will be considered for EMF as well. So if someone tells you what is the average value of EMF, what is the average value of EMF over a full cycle? E average is equals to what? Tell me. Over a full cycle, it will be 0. For a positive half cycle, it will become 0.637 times of E naught, right? And so the value of EMF is also this much. Is this clear? There is a very small note over here. This is the note first point. We'll give 5 or 6 lectures on alternating current as well, guys. Na? A little bit more भी हो सकते हैं, but I'll try to finish alternating current within 6 lectures. It may go to 8, but I'll try my best to finish it within 6. Done? Suppose, guys, if I talk about also for a very long time interval, that implies T2 is way bigger than T1. Small T2 is way bigger than T1. Why does it so? If I start, suppose if I have started the current to flow and it keeps on flowing for an infinitely long time or a very large time. Though, can you see over here in this particular case, this T2 is much greater than T1. Then can I say this particular thing, the value of T2 minus T1 will be way bigger than the integration of whatever the current is from T1 to T2, right? Because this will be in the sinusoidal form, right? So this thing will be a finite thing, and this thing, since it is very big, then it will be infinite, right? So what is finite divided by infinite? It is 0, right? Yes or no? Is finite divided by infinite is 0, right? Anything divided by infinite is 0. So can I say for a very long time the value of average current or average EMF, it becomes 0? Please note it down. Done. Guys, is it clear? ये दो derivation are very important. We'll do some more derivation which are important from school point of view, and then we'll see some questions, and फिर the main topics will start. Now, please write new heading: RMS value of an AC or AE. What is AE? Alternating EMF. Okay, alternating current or alternating EMF. So RMS value. What does RMS value means? RMS means root mean square value. It is also called as the virtual value, or it is also called as the effective value. So it has many names. Is it clear? What is this RMS? Please remember, for RMS, first square, then take a mean, and then place root. So suppose if you have a current for I equals to f of t for this instantaneous current, and in spite of naming it, let's say this. So for current I is given as a function of time, how do you find out the RMS value? How do you find out the RMS value? See, very easy. First of all, whatever this current is, square it. So what will be the square of I? It will be I square, right? Yes or no?
Yeah.
Yes, sir.
After calculating I square, this I square will become some other function, right?
Hmm.
So that function ka, how do you calculate the mean value in between two time periods? This is the main formula to calculate the mean value in between. So is it the average value of I square?
Yeah.
So it's basically I square ka average. Please remember, it is not I average whole square. It is basically what? The average value of I square. In spite of writing it like this, I am writing it like this. So this will be I square in conical brackets I am writing. Okay. So basically what does this mean? The average value of function I square. Okay. After this, what will you do? I RMS is basically the root of this I square ka average value. So what is the final formula? I RMS is equals to under root of I square average, which is basically 1 upon T2 minus T1 from T1 to T2 I square T2. Is this clear?
Yes, sir.
So please write down this formula. So now you understood where exactly this root mean square thing comes. Root mean square. So that's why it's named as RMS. Clear?
Yes, sir.
Yes,
Check.
sir.
So basically this RMS current is denoted by many names, na? Please, I can write it as IRMS, I can write it as IV, I can write it as IE. It's up to us whatever we want to write. Okay,
Yes, sir.
okay, so we'll see how exactly we'll use this formula in the next class. Okay?
Yeah.
Okay,
Yes, sir.
and we'll see the physical
Thank you, sir.
significance, the graphical significance of the same thing. Okay, guys?
Yes, sir.
Okay, sir.
ठीक है. अच्छा, by the way, if possible, you people try to integrate this on a rough piece of paper. If possible, with the help of this formula, try to apply. I told you the method, no? First you will do what? You will square it,
Well,
then you will
average.
take the average and then take the under root. एक बार try करके देखना. Although we'll be doing it. Don't worry.
Okay,
Just try
sir.
to do it on your own so that at least your understanding of this concept, this formula will become easier. Okay?
Okay, sir.
So
Yes,
what
sir.
should be limits?
Limits, it's up to you. Over a full cycle, over a half cycle, it's up to you. You can try both. You can try to only one. I just want you to be aware of this formula. At least थोड़ा सा मतलब some problems you can do. है ना?
Okay,
Yeah.
sir.
Chali. Thank you very much. We'll see you again in the next class.
Thank you, sir.
Thank you,
Okay.
sir.
Thank you, sir.
Okay. Bye bye.
Thank you, sir.